Now students, this is the time when we should come over to the next question in the series, and the question is question number 17. Let me read out the question for you. Question number 17 says that a reaction is at 1 bar pressure is non-spontaneous at low temperature, but this becomes spontaneous at a high temperature. You have to identify the correct statement about the reaction among the following. So it says that there is a reaction which is being carried out at 1 bar pressure. The reaction is given to be non-spontaneous when you have low temperature, whereas the reaction is given to be spontaneous when you have a high temperature. Now we know that if I ask you to write down the relationship between Gibbs free energy, enthalpy and entropy, you can say delta G is equal to delta H minus T delta S. When the temperature is low enough, the reaction is given to be non-spontaneous. That means you have been given that delta G value comes out to be positive. So this positive value will be equal to delta H minus T delta S. Since this temperature is a very low value, that means I can say that delta H will be positive and delta S will also be positive. Because if this is positive, whereas T is a small value and this is positive, then only we can say that the whole delta G comes out to be positive. Fine enough. If taking the same thing, I say that when the temperature is high, then the reaction becomes spontaneous. That means reaction delta G becomes negative. So I can say that negative is equal to delta H minus T delta S. Now when the temperature is high, then only this negative factor will contribute and hence delta G will become negative. Again, this thing is possible only when both delta G and delta H and delta S are positive. So coming over to the options that have been given to us for this particular question, the option says that delta H is negative while delta S is positive. Both delta H and delta S are negative. Delta H is positive while delta S is negative, and the fourth option is both delta H and delta S are positive. And hence I'll say option number 4th will be the correct option for this particular question. So students, having done with question number 17th, now let us come over to question number 18th. Let's see what does this question number 18 says. So question number 18 says that the amount of arsenic pentasulfide that can be obtained when 35.5 grams of arsenic acid is treated with excess of H2S in the presence of concentrated HCl. You have to assume 100% conversion is taking place. Now students, let me first of all say arsenic pentasulfide is As2S5 and arsenic acid will be H3ASO4. So if I write the reaction, you will say H3ASO4 will be reacting with H2S, which is given in excess, and this will be forming As2S5 but plus water. But students, a very important thing to be kept here in mind is you need to balance the reaction. So if I ask you to balance the reaction, you will say 2 moles of arsenic acid will be reacting with 5 moles of H2S to form 1 mole of As2S5 and 8 moles of water will be produced in this case. Now this has been given to us as 35.5 grams. This is given to me in excess and I need to find out the number of moles of As2S5 being formed. Looking over to the reaction, I can very easily say that 2 moles of H3ASO4 will be giving As2S5 equal to 1 mole. That means 2 times 141 grams of H3AsO4 will be giving As2S5 is equal to 1 mole. That means 35.5 grams of H3AsO4 will be giving As2S5 equal to 1 divided by 2 into 141 multiplied by 35.5 moles, and if you solve it, it will come out to be 0.125 moles. Let's see what are the options that have been given to us for this particular question. So my goodness, first option is 0.125, and hence I'll say option number 1 is the correct option for this particular question. Now students, done with question number 18th, let us come over to question number 19th in this particular case. So question number 19 says that an organic compound contains carbon, hydrogen and sulfur. The minimum molecular weight of the compound containing 8% of sulfur is, and the atomic number of sulfur you have to assume as 32 AMU atomic mass unit. See, it says that you have an organic compound, and this organic compound contains only carbon, hydrogen and sulfur. So you need to tell, so it is given that the minimum weight of the compound is to be told so that sulfur comes out to be 8%. Now since he is referring sulfur to be 8%, let's say the molecular weight is X. So I'll say that 8 over 100 into X will be coming out to be 32 AMU. Now this will be possible when X comes out to be 32 times 100 divided by 8, and it comes out to be 400. That means if the minimum molecular weight is there as 400 grams per mole, then only the minimum percentage of sulfur will be coming out to be as 8%. Moreover, students, you can also go through this question in another way, the normal traditional way that we use to name the compound. Like first of all, you have to write carbon, hydrogen and sulfur. Now let's say how much percentage of each is given to me. Since sulfur is given to me as 8%, let us say the percentage of carbon is Y% and hence the hydrogen will be present as 92 minus Y% because 8% is sulfur. Now once we have written this, I ask you to divide it by the molar weight. So you have carbon as Y by 12. Here it comes out to be 92 minus Y by 1, and here it comes out to be 8 divided by 32, which comes out to be 1 by 4 in this particular case. If I ask you to divide it by the simplest ratio, this comes out to be Y by 3. This again comes out to be 92 minus Y and into 4, and this comes out to be 1. So I am simply multiplying it with 4. So if I multiply it with 4, it becomes Y by 3. If I multiply it with 4, it becomes 92 minus Y by 4, and if I multiply it with 4, I get 1. Now why I have done it 1? Because it is giving me the percentage of sulfur has to be given. Now you take anything and the formula of compound will become C times Y by 3, hydrogen 92 minus Y into 4 and sulfur 1. Now you take any percentage of sulfur, or any value of Y. Let us take the value of Y as 1. So if I take the minimum value of Y, so this becomes, or let me say Y will be taking at 3. So this becomes CH 92 minus 3 times 4 and S. So you take any value of Y and find out the percentage of sulfur, it comes out to be 8%. That means the total comes out to be 400 only, and hence this is the alternative method. Let me look into the options that have been available with us. The options that have been given are 200, 300, 600 and 400, and hence I'll say option number D, which says 400 grams per mole, is the correct option for this particular question. Now coming to another question in the series, let us look forward to question number 20th. Now question number 20th, it says that the test to distinguish primary, secondary and tertiary amines is. So students, this is again a very easy question. We know that primary, secondary and tertiary amines can be distinguished by Heisenberg test or Heisenberg's reaction. Now what is there in this Heisenberg's reaction? You should remember this thing, that when PHSO2Cl is treated with amine, which is either a primary or a secondary amine, then the compound so formed will be poorly soluble, and this compound will be precipitating as a solid precipitate. However, if the same compound PHSO2Cl is treated with a tertiary amine, then there will be the formation of a water soluble sulfonate salt, and hence this can be used for the distinction between primary, secondary and tertiary amines. Let us go for the options available. So the options are carbylamine reaction, mustard oil test, C6H5SO2Cl and Sandmeyer's reaction. So students, option number 3 is the correct option in this case, because whatever I have written as PHSO2Cl is nothing but C6H5SO2Cl, and hence marking this option number 3 as the correct option for this particular question. Now let us come over to question number 21 in the series. So question number 21, it says that the solubility of nitrogen in water at 300 Kelvin and 500 torr partial pressure is 0.01 grams per liter. The solubility in grams per liter at 750 torr partial pressure is. So this is again a very simple question, and you can say that the solubility of nitrogen in water, you need to find the solubility of nitrogen in water. This is 0.01 grams per liter given to us when the temperature was 300 Kelvin and when the pressure was, let's say, 500 torr. Or let's say the partial pressure is given to be 500 torr. Now we know that the partial pressure is directly proportional to the mole fraction. Also I can say mole fraction is nothing but a kind of solubility of nitrogen in water. So I can say partial pressure is equal to Kh times mole fraction X, and hence I can say Kh is equal to P divided by X. Now Kh for a particular gas, nitrogen in water, will be same because the temperature is not changing. So I'll say P1 over X1 is equal to P2 over X2. If I ask you to replace the values, you will say 500 torr divided by 0.01 grams per liter is nothing but 750 torr divided by X2. On further solving this data, the value comes out to be 500, torr and torr get cancelled. So we'll simply say X2 value comes out to be, so I can say X2 value comes out to be 750 into 0.01 grams per liter divided by 500, and it comes out to be 0.015 grams per liter. And you can look into the options and you can find that option number 3 is the correct option for this particular question. Now, having done with this question, let us move over to question number 22. So question number 22, if I look forward to the question, it says that you have to identify the correct trend which is given below. The atomic number of titanium is given to be 22, chromium is given to be 24, and molybdenum is given to be 42. Now let us look for the options. The very first option says delta O crystal field splitting energy for CrH2O6 2 plus is greater than molybdenum H2O6 2 plus. Dear students, you know that the molecular weight or the molecular number of molybdenum is much greater as compared to that of chromium. And we know that as we go from 3D to 4D to 5D series, the value of CFSE increases. because of the poor shielding of D and F orbital in the case. But this option says something else. It says that the CFSE for chromium compound is greater as compared to the molybdenum compound, and hence this will be the wrong option. Coming over to option number 2, it says that, okay, let me see the option number 2 which is given to us. It says that molybdenum, the delta O of CrH2O6 2+ is again greater than molybdenum H2O6 2+. So the same statement is here in option number 2 also. And I can say this is wrong option. Coming over to option number 3. It says that delta O of CrH2O6 2+ is less than that of molybdenum. Fine enough. Whereas the second option is TiH2O6 3+ is less than, so the second option, first is correct, but this says that TiH2O6 3+ will be less as compared to TiH2O6 2+. Again, this is a wrong statement, dear students. Why? Because we know that if there will be more charge on the central atom, then more will be the attraction with the ligand. The ligand will be more easily approaching the central metal ion, and if the ligand approaches more nicely to the central metal ion, there will be more of splitting in the energy values, and hence this is a wrong option. Now let me coordinate with the fourth option. The fourth option says that CrH2O6 2+ is less than molybdenum H2O6 2+. A very good statement, fine enough, because as we move down the group, delta O value increases. And another thing says that you have TiH2O6 3+ is greater than TiH2O6 2+. Again, this is the correct statement. So I can say option number D will be the correct option for this particular question, number 22. Now, let us try to come over to the question number 23. Question number 23 states that which intermolecular force is responsible or is the most responsible in following xenon gas to liquefy? So we here want like the intermolecular forces which are responsible for the liquefaction of xenon gas. And let me tell you, xenon gas is a noble gas. That means it is also, I can say, it is a monoatomic gas. Now, if I am talking about the liquefaction of xenon gas, it means that all the molecules have to be brought closer to each other. Now you know that a xenon molecule is not at all polar. It has got no percentage ionic character. But we know that there will be electron cloud around the xenon nuclei. Now if the xenon nucleus is having some electronic cloud and you know that the electrons are constantly moving, that means at any particular point of time, so let's say at a particular point of time, there will be more electron density on the one corner and little less electron density on the other corner. That means I can say that there will be an instantaneous dipole which will be introduced in the xenon atom. Now once the instantaneous dipole is induced in the xenon atom and suppose it goes and find out another xenon, then this positive part will be making this as negative and the other part as positive. That means we can have a kind of instantaneous dipole and then there will be induced dipole. So I can say that instantaneous dipole induced dipole interactions will be responsible for the liquefaction of xenon gas. So the first option was ion dipole. See, there is no ion, so the ion dipole cannot be the correct option for this particular question. Second is ionic. Again, there is no ionic stuff in the xenon molecule, so this is also not the correct option. Third is dipole-dipole. there is no dipole as such in the molecule, so again this is not the correct option, whereas the fourth option will be the correct option for this particular question. Now students, done with question number 23, it's the time that we should move over to question number 24. Now question number 24 says that the artificial sweetener that has the highest sweetening value in comparison to cane sugar is. That means we have to talk about that particular artificial sweetener which has got the highest sweetening value. Now students, a very important topic here where you study it in sugars, you know that elitame, this is that particular artificial sweetening agent which has got highest sweetening value. Moreover, this is one of the most important property of elitame, and the most important property, not only the property, it is one of the drawbacks of elitame, that it has got such a high value of sweetening agents, or it has such a high sweetening value that it can be responsible for diabetes in many patients, which cannot be controlled. So I can say, if you look into the option, elitame is given as option number 2, and hence you can say this is the correct option for this particular question again. Now let us come over to question number 25th in this case. So coming over to question number 25. Question 25 states that the plot which shows the variation of minus ln Kp versus temperature for two reactions. So the two reactions which have been given to us are metal solid is going to react with half of oxygen gaseous state, and this is going to form MO in the solid state. And the second reaction is carbon solid is going to react with half of oxygen in the gaseous state in order to form carbon monoxide in the solid state. Now the plot is given to us and you have to identify the correct statement for this question. Let us draw the plot once. So this is the plot, and this is minus of ln Kp, and this is temperature. You have one particular curve like this. This curve is for metal to form metal, M to form MO, and the another curve is something like this for C to form CO, and the value is 20 and the temperature is 1200 Kelvin. Now students, listen very carefully to the explanation which I'm going to give for this particular question. We know that delta G is equal to minus RT ln K. That means if I take R as a constant, I can say delta G is minus T ln K, or I can say minus of ln K times T is nothing but delta G. That means whether I'll be talking about minus ln K or I'll be talking about delta G, that will be one and the same thing. Now the first option says that at temperature greater than 1200 Kelvin, delta G and minus ln K are proportional. This is what we have to keep in mind. Now it says that when temperature is greater than 1200 Kelvin, minus ln K for carbon to form carbon monoxide is greater than minus ln K for M to form MO. That means delta G for C to form CO will be greater than delta G for M to form MO. That means C is gonna get oxidized. So this is not the correct option, because like what has been given in the option is not matching with what is there. Let me now try to come over to option number 3. It says that when T is less than 1200 Kelvin, we can conclude from the graph that minus ln K from C to CO will be less as compared to minus ln K from M to MO. That means delta G for C to CO is less as compared to delta G for M to MO. That means oxidation of carbon is unfavorable. And hence this is the correct option which we have in the options. Now the fourth option says that MO solid plus carbon solid is gonna form M solid plus CO gaseous is spontaneous when temperature is less than 1200 Kelvin. Again, I'll say this is not the option which is acceptable to us. So I'll simply mark option number 3 as the correct option for this question number 25.